Hey guys, how's it going? So to continue on from our last video, I proved the sine law, and just kind of reiterating what we're doing here is in Math 10C, you guys learned how to solve triangles that were right angle triangles and how those worked. So in Math 20, we're kind of expanding our practice so that we can kind of solve triangles that are not right triangles as well. Okay. All right. So guys, it's kind of the best practice for a lesson like this is when you get a question like this. I'm gonna say if you think you know how to do it, okay, pause the video now and do the question on your own sheet of paper, okay, and just kind of follow, and then watch my work afterwards and kind of make sure that you were doing it correctly over there, okay. If you need to see me do one first, okay, but then the next one, or pause it after I've done the video and just go ahead and just kind of do the work for yourself as well, okay. Guys, it's important that you guys, if you guys are just watching videos, that's not the optimal way to learn math. Okay, you really need to be able to kind of do the question on your own and kind of get some repetition and practice in there so that you're doing these questions well. So the sine law that we proved in the last video was this guy. And in formula sheet, they actually show one more, sine C over C. Okay, now this is, very confusing when you see it's a formula like this, which has two equal signs in three parts. Okay, we're only ever going to use two parts of this equation over here, like this, which can use these two. Now again, the way that we label these triangles, if this is my angle big A, that means this is going to be little a. If this is big B, this is little b. Okay, big C, little c over here. Okay, so the way I set these questions up is I like term, I call it the barbell method. So what I mean by that is if I'm going to circle an angle and then I'm going to go draw a line to the side on the opposite side like this, and then I'm going to circle this angle and this side length and then draw a line between them like that. Okay, so doing this, and it was called the barbell method because like I said, this guy over here looks like a barbell when you're lifting weights, and so does this guy over here. Okay, all right, so what we have is we have sine 40 over x equals sine 85 over 12. Okay, so do a bit of algebra, get x by itself. I'll multiply both sides by x, multiply both sides by 12, and then divide both sides by sine 85. Like this. Okay, those cancel there. So we have 12 sine 40 over sine 85 equals x. And of course, it's happening. Okay, so I'm just going to go to my calculator screen now. The thing we need to memorize, guys, is that your calculator has to be in degree mode for this unit. Okay, so if you guys press the mode button and you're going to go down, and you need to make sure that the degree is highlighted. So go over here and then press enter. So now we know that we are in degree mode. It can't be in radian mode, guys. If you're in radian mode, you're going to get all the questions wrong for these type of questions over here. Okay, so I'll just quit out of this, and we had 12 times sine 40, close your bracket, divided by sine of 85, close your bracket, equals this guy, 7.7429154447. Okay, so I'm just going to write this down as x equals 7.74 ... and that means x equals 7.7 centimeters. Okay, so I'm rounding to the nearest tenth, which is one decimal place, just like that. All right. Okay, so guys, this question over here is just the same as example one. So I'm going to say, guys, pause the video and go ahead and try this question on your own and see how it goes. Okay. I'm just going to go ahead, guys, like that. So just kind of when you're hopefully you've unpaused by now and just kind of compare your work to the work I'm going to do now. Here's my first barbell. I'm going to circle those two and connect them like this. So there's barbell number one. Now I have barbell number two. Now the barbell method works. If you see what here is, if I draw two sets of barbells and I have one unknown value here, the barbell method works. What we're going to see later on is sometimes you're going to try to do barbells and you're going to have two unknowns, and unfortunately the barbell method is not going to work in those cases there. All right, so what we get is we get sine 38 over x equals sine 65 over 25. And now we're just going to solve it for x. Multiply both sides by x, multiply both sides by 25, divide both sides by sine 65. Sine 65. So we get 25 sine 38 over sine 65 equals x. Guys, I'm just going to fire this to my calculator in front of me here. All right, so we get x equals 16.98. A bunch of decimals after that. So if I round this to the nearest tenth, I can get x equals 17.0 centimeters. All right, so this is my final answer for this guy over here. Okay, example 3. So similar, except now we're solving for an unknown angle. Okay, so if you have an unknown angle, we're going to set up in the same way that we did before. So we have this guy is 41 degrees, and we know this is 55 centimeters. Here is barbell number 1. I circle x, circle 37, connect those guys. There's barbell number 2. So we get sine x over 37 equals sine 41 over 55. Okay, we need to figure out what this angle is here. So what I'm going to do is multiply both sides by 37, get this guy over here, and 37. So we get sine x equals 37 sine 41 over 55. So I'm going to calculate here 37 times sine 41 divided by 55 equals 0.44. So sine x equals 0.4413488013. Now, guys, important here. Since I need to use this number for another calculation over here. So in that case, guys, keep all the decimal places you can. Don't round anything too soon over here. Okay. All right. So this is not angle x. Now, if you remember back from Math 10, we have a way that we can get angle x from an equation like this. What we want to do is we want to be able to take this x and this number over here, and we want to be able to flip them. Mathematically, flipping something like this is what we call inverting it, or taking the inverse. Okay, so I'm just going to put an arrow over here. So what we're doing is we want to go sine inverse, which on your calculator is the -1 button. Sine inverse of 0.4134888013, and that equals x. So I'm going to sine inverse, and of course this keeps happening. All right, so we have sine inverse of that long decimal, and we get 26 degrees. All right, so that means x equals 26.18997167. We're just going to round this to the nearest degree. So the nearest whole number is 26 degrees. All right, so that's how that guy works there. Same as last time, guys. So example 4. No, it's a little bit trickier over here because, well, I have these guys I can circle, but I don't have anything to circle on this side over here. So here we're going to do first. I'm just going to call this angle y. And I'm going to connect those two like that. Okay, and then if I know this angle, and I know that there's 180 degrees inside any triangle, I can add up these two together and then subtract that answer from 180 to get this angle over here. Okay, so to do this one, I'm just going to do the same thing as I did the last one. I have sine y over 125 equals sine 47 over 93. Multiply both sides by 125 like this. They cancel. So we have sine y equals 125 sine 47 over 93. On my calculator, All right, so we get sine y equals 0.98. I'm just going to put a dot, dot, dot at the end there. Now, what this tells me is that there are more decimals afterwards. And when I put it in my calculator, I'm going to use all the decimals, but I'm just going to write it down like this for the moment. So now it's going to be sine inverse of 0.98 dot, dot, dot equals y. So second sine of that decimal, all those decimals in there, and we get y equals 79.4208 dot, dot, dot. So we're asking for the nearest degree. Okay, so that means y equals, call this guy 79 degrees. So how do I figure out angle x? Well, if I just go 47 plus 79, we get 126. And then if I just go 180 minus 126 equals 54 degrees. And we get 54 degrees here. And that's going to be our last unknown angle that we're asked to solve over there. All right, guys, hope this makes sense. Okay, so guys, keep up with your textbook practice questions and go try a bunch of these guys as well, and hopefully this makes sense. Next topic is called the ambiguous case, and it's a little bit tricky to understand, so I'll make a video for that one as well. All right, guys, see you in the next one. Bye.